let's just go over all the stuff that we did in class last time. We introduced a brand new topic, which I said was a little bit, let me get my thoughts together here. It was a little bit less intuitive than the other stuff that we've done before. Before we talked about confidence interval, or we talked about mean, histograms, pie charts, probability, all the things that you kind of hear in everyday life. But confidence intervals is a little bit different because, well, no one really ever talks about the confidence interval. Now, to kind of give you intuition on the subject, I showed the range game on The Price is Right, and the rising and falling red interval is a confidence interval. And if you had a really large interval, a lot of people would win the game, but unfortunately, it wouldn't mean that much. And if you had a really tiny interval, not many people would win the game, okay? The goal is to make this interval large enough so that enough people win the game to make it interesting, but small enough so that it's actually meaningful, okay? Next, we decided on how to create this interval. And before we even did that, we had a bunch of different symbols, terms, things that we talked about. So before we go into this, let's just review what we did, okay? So let's see, we're given questions, specifically this example, where we're given the sample size, which was 100. They were selected to take part in this experimental approach to reading. And in this sample, they found that the sample mean was 67.3 and that the population standard deviation was 15. Okay, so we're given all this information and it's asking us to find the population mean. I told you before, there's no way to actually calculate like a specific number for the population mean with this information. We're just not given enough information for this. But what we can do is we can create an interval that may or may not contain the population mean. Okay. Now to do that, we had this idea of the margin of error. Okay. And the way that we use this is we estimated the population mean using the sample mean. And then we added and subtracted the margin of error to 67.30, which was our sample means. Okay. Now, I kind of gave random margins of error. So instead of just telling you a number that the margin of error is, we have a way to calculate this value. Let's just say I wanted to be 95% confident in our interval. Okay, and I'll go back to what that means. What we'll do is first we'll find the standard error, which is literally what you did on the quiz, sigma over the square root of n. Okay, you're going to find the critical value, which is found using this handy dandy chart. Okay, and then to find the margin of error, you're just going to multiply the two numbers that you found. So in this example, we got 2.94. To make our interval, you take the mean, you're going to add 2.94, you're going to subtract 2.94, and that's how we got this interval here. Okay. Now, in statistics, I don't know if you might have heard this before, but the answer is really important, but how you say the answer is sometimes even more important. Okay, so this is kind of how statistics is a little bit different than like an algebra class or something like that. You can get points taken off for saying the wrong thing. Okay, there's a very specific way that you say this answer, and this is how we do it. We're going to say, because we have this interval, we are 95% confident that the thing that we're looking for, or the population mean, so population mean, remember that another way of saying this is mu, okay, is between the two numbers that we found, 64.36 and 70.2. It is very important that you use this phrasing when you explain your answer. If you don't, you risk communicating the wrong thing, which is, I think, what we're going to talk about next. Okay, it's very important to say it using this phrase. We are 95% confident that blank. Okay, we'll talk about what that means in a second. Any questions so far? Yeah, so you can use this instead of population mean. I think everyone's done writing. Let me explain why this wording is really important. I think it's kind of confusing. what this is. And before I can even explain why it's important, is I'm going to talk about what this confidence level actually means. Okay. So I kind of threw this level at you, which I actually always will do. But I told you that I wanted to be 95% confident. What does that even mean, right? Okay. What this means, and it's kind of hard to explain thoroughly, but I'll give you an idea of what this actually means. Okay. When I construct this confidence interval, 64.36 to 70.21, I actually don't know if the mean is going to be in there. Okay. It's not sure if the mean is going to fall between those two numbers. Okay. Gosh, what am I about to say? I don't want to say something wrong. And this is very. Okay, here we go. Sorry about that. Okay, in this specific example, we constructed a 95% confidence interval. We had a specific sample with its own sample mean, and we knew what the standard deviation was. Okay. If you take at this picture here, it looks a little bit confusing, but what this shows is a bunch of the confidence intervals. Okay. In this case, we found a 64.36 and 70.21 to be one of our intervals. So maybe if I selected like this one here, actually, let's not do that one. Let's do this one to here. Okay. Let's say that that was the confidence interval that we found. Well, one endpoint would be the 64.36, which I'm trying to remember what the number actually was. 64.36 to 70.21. Okay, those are the endpoints of that interval. Okay. Now, I don't know if the population mean falls between those two numbers, but using this picture and the fact that I selected this specific interval in that picture, I know that the true population mean does fall in between those two numbers. So let's just say that's true. Okay. Now, what the 95% confidence means is, what if I took different samples? So what if I took even more samples, maybe 1,000? Okay. So maybe I did 1,000 samples and I found 1,000 different confidence intervals with 95% confidence. Some of my intervals won't contain the population. Okay. Some of them will, like the one that I found. Okay. So this one will contain the population mean. Unfortunately, looks like this one doesn't. Okay. What 95% confidence means is 95% of these intervals, if I take a lot of samples, like 1,000 or 1,000,000, 95% of these will contain the population mean, 5% won't. Does that kind of make sense? Okay, so we're not actually talking about the probability of the mean being in the confidence interval. We're talking about the probability of, if I took a bunch of samples, did this whole process, 95% would be right or would win the game, right? Okay, so this is why it's kind of important to say we are blank percent confident that the population mean falls between this, because if you say it a different way, you might communicate the wrong thing. Okay. All right. Let's go through a few examples here. A little bit less step by step on this one, but let's just say we have. Why am I blanking out here? I think I'm so excited about Halloween that I'm like not thinking right. Okay, let's say we have a sample of size 50. This sample has a sample mean of 7.1, and the population standard deviation is 2.3. Okay. Before I do the problem, let's just write down a few letters here. What does 50 represent? N, good. Of course, they gave us that X bar was 7.1. The population standard deviation is 2.3. What symbol is that? Sigma, good. Okay. We want to construct not a 95% confidence interval, but a 90% confidence interval for the population mean. Okay. So let's just go through this. Looks like we have to figure out what the margin of error is first, which means looking at our page, it looks like we have to find the standard error first. Okay. So our first thing that we want to do is to find the standard error. Okay. What's the equation for standard error?
Take 1 over the square root of the sample size.
Perfect. Remember, same thing as what we did in the last section to find the standard deviation of the means, right? So same formula, same process here. Okay. Well, plugging in, looks like sigma is 2.3, n is 50. Okay. Now, I recommend doing the square root first, writing it down and doing the division. I'm kind of a hypocrite and I didn't do that in my paper. So this ends up being 0.325. All right, next we have to find the critical value, right? That's the other number that we need to multiply by. So critical value, okay. We have a 90% confidence interval. Remember, critical value is found using the handy dandy chart that I will always give you. Looking at the chart, what is my critical value? Good, right? Looking at the chart, 90% means 1.645. We're all good. That's our critical value. So using the chart, you just look under 90 and it is 1.645. Okay. Any questions so far? All right, moving on. Looks like we need to find the margin of error, MOE for short. Okay. What two numbers am I multiplying together? Good, right? We're going to multiply the standard error times the critical value. And that gives me 0.325 times 1.645. And that gives me 0.535. Okay, so the margin of error is what I want because that's the thing I'm adding and subtracting to. Okay. So I know I need to add and subtract. What number am I adding and subtracting from? Give you a hint, it's the number we haven't used yet. Yep, X bar, right? Usually with these word problems, if you're not using a number, that's kind of a hint that you might want to use it next. We're adding and subtracting from this because we want to find the population mean. The number closest to the population mean is the sample mean, right? That's our best guess. Okay, so our next step is we are going to add and subtract our margin of error, 0.535, from 7.1. Okay, now if you like setting up the interval, that's fine. I don't think we have enough space to do that, so I'm just going to take 7.1, add 0.535. That gives me 7.635. I'm also going to take 7.1 and subtract 0.535, and that gives me 6.565. Okay, so once I'm done adding and subtracting, I found the two numbers that I'm looking for, right? And my interval is literally 6.565, comma, 7.635. Okay. Why did I put the 6.565 first? Yeah, smaller, right? The smaller number goes first, the bigger number goes second. Okay, this is my confidence interval. Okay, I know I didn't ask you in the question, but how would I say this in words? Using the correct phrasing.
We are 90% confident
Mhm.
that the intervals are those two numbers, right?
Close,
Like that?
close, pretty much like that.
Oh, so the population mean between us.
Good. Instead of writing population mean, I'm lazy. I'm just going to write mu, is between the two numbers, 6.565 and 7.635. Okay. Any questions on example number 2? All right. Example number 3 is very similar. I want you to give this one a go. I know there's a lot of steps, but I think I'm pretty confident that we can do this one. Give you a few minutes for this. All right, as I'm walking around, looks like everyone's on the same page. Looks like we're doing good. But let's just go over this real quick, just so we have everything all at once. We have a sample size 42, mean is 9, population standard deviation is 1.5, and we wanted to do a 20% confidence interval, which seems kind of bad, honestly. 20% doesn't seem like the best idea, but let's just do it anyway. So I got Jessica, you wrote up all the symbols, which I'm not going to ask you to explain. But do you want to explain how you got the standard error?
Yeah, so I did standard deviation of the square root of the sample size, plug the numbers in, and then I went and did the division for them, the square root of that, and I got 0.2.
Sounds great to me. Very nice. Any questions on standard error? That's good. All right. Next, Kamara, you wrote up the critical value and the margin of error. Do you kind of want to explain how you got both of those? Mhm. Good. Just multiplying two numbers. Great job there. Any questions so far? Sounds good. Finally, we have to find what our interval actually is. And Emily, do you want to explain how you got this one? Perfect. And now we have our interval. Remember, the smallest number goes first, the largest number goes next. Anyone want to take a crack at explaining or interpreting this interval in words? I saw it on some of your papers. Yeah, Caroline.
They're 20%
You got it.
They're 20% confident that the population is 8.941 and 9.05.
Perfect. Let me actually write that out so we have it. The way that we would write this, I know I didn't ask it in the question, but we are 20% confident that the population mean mu is between 8.941 and 9.058. All right. Any questions on example 3? All right, let's move on to next. We're actually going to put everything together now. We have pretty much all the information, or we did the hard part of this. Let's just kind of put it together, all the information that we did. Okay, before we talk about putting things together, I want to talk about the standard error a little bit. Remember, the standard error is what we did to find the margin of error, and it was sigma over the square root of n. Where do you think we got that formula from? Yeah, it was on the sheet. Okay, yeah, it was on the sheet. That's a good one. Yes, we got it from the sheet, but it was also on our quiz, right? I didn't tell you this, but the standard error formula is actually derived from the central limit theorem. Okay, so you actually have to use the central limit theorem to even do these confidence intervals. And because of that, remember that question where the sample size has to be bigger than 30 and the question has to say a normal population? That also has to be true to do these confidence interval questions. Okay, so I didn't tell you that, but in order to do these questions, we have to figure out if n is bigger than 30 or if the population says it's normal, which I didn't write here. Okay, so putting this together, when we do a confidence interval question, the first thing we have to do is see if we can actually do it. Okay, now in this class, I'm probably not going to give you a question where you can't do it because, well, it would be kind of useless to give you a big question like that, where you don't actually have to do anything. But I do want you to explain why you can do the question. Okay, so before you do it, you're going to check your assumptions. You're going to, I'll explain the next part, but you're going to say if the sample size is bigger than 30, or if the question says the population is either normal or approximately normal. Okay, don't really worry about the other thing. Sigma is given to us in the question. We'll talk about that in the next section, but I might ask you it during this. So one of the assumptions for this question is also that sigma given to us. Don't worry about why I'm asking that. Okay. Second of all, we're going to find the critical value, right? Using the chart, find the critical value. Third step, find the standard error using the formula, right? And then you're going to find the margin of error. So that's all on step 2 and 3. Oh no, you okay?
Oh, no, sorry, guys.
Oh no. Oh. All right. Fourth of all, you're going to write the confidence interval. Remember, it's the point estimate, which is the sample mean, plus or minus the margin of error. You can write it in this form, which I told my students last semester to do, or you can also use like the parentheses notation. I think that one's a little bit easier. Then you're going to interpret your interval by filling in the blanks. We are something % confident that the population mean is between the two numbers that we found. Okay. Before we actually do an example, let's just suppose that we did a 90% confidence interval and we got these two numbers. I think I harped on this long enough. It is okay to say that we are 90% confident that the population mean is in the interval. What's not okay to say is that the probability of mean being in the interval is 90%. Okay, that's actually not true. Kind of hard to explain why, but it's not true. Okay, what we are interested in is if we take a bunch of those intervals, bunch of those samples, 90% of those will contain the population mean, not the same thing. Okay, you can also say this, which the textbook says is okay. I think the first one's easier to memorize, so don't really worry about the other one. Okay, let me take a look at what we have left. We got example 4, example 5. Part of me is like, I kind of want to do this all in one class. All right, how would you feel if I let you out a little bit early?